This work builds on an audio-only masking approach to multi-talker speech recognition developed by Tripathi and his colleagues at Google. It adds visual features to this setup and demonstrates the impact the visual features have on word error rate for an overlapping speech audiovisual speech dataset. The goal of the work is to simultaneously decode utterances from overlapping speakers, as opposed to trying to decode utterances from a single speaker in the presence of background speech. As an example of the problem, I have a video made from the mouth tracks of two overlapping speakers. The transcriptions at the bottom of the screen are obtained from an audiovisual multi-talker model. The text in blue corresponds to the speaker on the left, and the text in yellow corresponds to the speaker on the right.
Yelling at you, I'm raising my voice to match your own because you want to play games, Ted, and people are dying.
That's okay, Chris. You're perfectly fine.
So the captions decoded for the overlapped speakers here are obtained over very long overlap intervals. These block diagrams describe how the audio-only multi-talker RNN-T model is an extension of the single label encoder RNN-T. The multi-talker model adds a masking model, and for the two-speaker case consists of two passes. In the first pass, a channel select index for the first speaker is appended to the encoded audio overlapping audio features. The utterance is aligned with the label sequence for the first speaker, and the RNN-T loss for that channel is computed. In the second pass, the channel select index for the second speaker is appended to the encoded audio. The overlapped utterance is aligned with the second label sequence, and the RNN-T loss for the second channel is computed. The overall loss is the sum of these RNN-T losses with the addition of a masking loss. This block diagram shows how the audio-visual multi-talker RNN-T extends the audio-only multi-talker RNN-T. It's still a two-pass approach as before. However, in this case, an attention network is used to provide an attention-weighted combination of the visual features associated with the mouse tracks from the two overlapping speakers. This bar chart provides an indication of the impact of the visual features on multi-talker word error rate. It shows a breakdown of the audiovisual and audio-only multi-talker word error rates across a percentage overlap in overlapping utterances. Percent overlap from 0 to 100% is displayed along the horizontal axis, and word error rate is shown on the vertical axis. The blue bars represent audio-only multi-talker word error rates, and the orange bars represent the audio-visual word error rates. It's clear from the chart that the word error rate for the audio-visual model is nearly uniform across a percent overlap, and that appears to be the main impact of using visual features for multi-talker ASR.